Okay, let's say that I wanted to find the slope given 2 points. Now, this is really just to look at how Excel can be really helpful at doing programming for us. So while we've been doing a lot of Mathematica, Excel is a really awesome thing to become good at. So let's say that we have 2 points. So our first point, this x1, y1 means our first point. So let's say it's like 2 comma 5. So x is 2, y is 5, and our next point is 7 comma 3. All right, and let's say I wanted to find the slope. Well, I know that the slope, I know slope is just rise over run, so I could calculate that slope, and the slope would be the change in y, which is 3 minus 5, divided by the change in x, which is 7 minus 2, and it will generate the slope for me. That's something I expect you to be fairly familiar with, just how to find slope. But using Mathematica now, we can create a program that will, for any 2 points, just immediately get the slope for us. So we're just going to do the same idea. So our slope is y, so I'm going to click on that y value, minus, and if I don't want to click, I could do, my y1 is b2, so I could just type in b2, divided by x2 minus x1, so the change in x. And if I enter, I expect to get the same value. But what's nice is, let's say I wanted to change to another point. So instead of 2, 5, let's say I actually wanted to look at 19, 5. Well, this slope automatically updated. This one didn't because it's static. It's set for only these 2 points. But this equation here is, oops. But this equation here is the general equation. So as I update these points, it automatically updates the slope. That's going to be really helpful for you because what you can do is you could create something that if you were given the known proportion and the number of trials and the number of successes, what you could do is you could calculate the z-value for a proportion, for a sample proportion. And that's what you're doing on your homework. But it's going to use the same idea that we just looked at, which is just to create reference cells. Maybe just to get you started, what I could look at is say, let's say my known proportion was 0.5, and let's keep it simple, flipping a coin. So 0.5, and I do 10 trials and I get 6 successes. So what I could look at is like, what's the difference in proportions? And so the difference in proportions would just be the experimental proportion, which is successes divided by trials, minus the expected proportion. So we're going to expect that to be 0.1, and it is. But then we'd need to, we're not done, then we would need to somehow incorporate the standard error into that. And I'll leave that up to you. Leave that for you to do.